see all of you here connected. Thank you very much. And now we come together to the panel that we are going to have it right now with the first round of speakers with the questions you put in the panel, and as well, please free to make questions. Laura will be moderate the panel. Really appreciate it. Thank you.
Thank you, Olin. Hello, my name is Laura Silva, and I am the academic leader of the Colombian Association of Petroleum Engineers, and happy to be here. Okay, so to start, we have this first comment from Yu Erping. He said, thank you for your presentation, Dr. Antoine Thomas. About the reuse of produced polymer, is it possible if the polymer molecule is destroyed after the shearing of the porous? And would you please give me more information on AI and machine learning on EOR projects?
Yes, can you hear me well, everyone? So
yes.
Good, amazing. I just want to correct something first. I'm not a doctor. I don't have a PhD, unfortunately. I didn't spend enough time in university, but still I'll try to answer the question. So the answer is yes. Sheared polymer doesn't mean that adding it to fresh solution will not help improve viscosity. So basically the studies that have been made show that even if you have sheared polymer, you can save between 5 and 15% of fresh polymer, both in the lab and in the field. You have field cases in Canada, for example, in the Lloydminster area, where people are reusing polymer, and they can save something between, in their case, 12 to 15% fresh polymer, which is a couple of millions of dollars a year, depending on the number of wells. So the answer is yes, you can reuse. And the second question about AI and machine learning, I will just give maybe two public cases. In the IOR conference in Tulsa that's just been closed a couple of weeks ago, there was an example from, I think it was Alaska, Hillcorp, Milne Point, where people are using machine learning basically to try and come back to the model to assess all the scenarios which can explain, for example, early breakthrough of polymer. Because when you have early breakthrough, you can look at different parameters, but the main one, of course, is reservoir heterogeneity. And it means you are wrong in your model, because if you cannot predict early breakthrough, it means there is a high permeability streak or fracture or something which either was here or which you have created that you have to take into account now. And so basically this kind of approach can more or less automatically go back to the model and assess the most likely scenario explaining the breakthrough. And still you have to check afterwards if it makes sense, because in some cases there is no physical sense between changing one or the other parameter, but still it's working nice. And AI, today, the most example I have is in CO2 injection for EOR, where basically people use AI to extract more information from seismic and refine models. I can send a couple of papers if you are interested, but I don't want to take too much of the time, so that I will stop here the answer to this question.
Okay, thank you so much. We have another question for you from Hank Sheen. He asked, what are the possible reuse options for produced polymer, especially the options that are already deployed in the industry?
I think there would be 2, maybe 3 maximum. So the first one is to reuse the polymer with fresh polymer to inject in the reservoir. So in the place basically where you are already injecting polymer to continue and displace oil. The other option I see, which has not been, I would say, is implemented, but without people knowing the benefits of that, is the produced water containing polymer can be injected into other parts of the field. You will have 2 benefits. The first one is polymer is a drag reducer, which basically means, like in the fracking industry, that you will decrease the pressure drop of your water flooding system injecting water in these zones, which can account for between 10 and 50% decrease in pressure drop, which is huge in terms of pumping energy. And injecting this polymer into zones that were not flooded, you can saturate the rock with this polymer and later decrease the absorption of upcoming chemicals. So that's the main 2 benefits I see from this possibility and reuse of porous polymer.
And we have a comment from Julio Herbas. He says, hello, Antoine. We have done some studies trying to address that, and results may be mixed depending on the reservoir location, water resources available, and water quality. Also, the CO2 price was affecting, but these economic studies were very basic, so I can only say that post-treatment of water was costly, especially in the case of Norway, where offshore installations are extremely expensive.
Yeah, it was the questions I asked to Ivan, so yeah, thank you for putting this up. Yeah, thank you.
Yes.
Okay.
Yeah.
Okay, and we now have questions for Ivan, although we realize you answered them on the chat, and we want to know if you want to comment something else or you want to add something.
Yeah, well, so I think that a point that I didn't add it into the presentation was that by using this hybrid effect, yeah, that has been also tested not only for polymers, but I can say that it has been also tested for surfactants, you know, like with the, we have done some tests here and that had came out like very positively. And also Arne Skoga in the University of Bergen in Norway has also been working towards that. And we see very good synergy of optimizing the water composition and then adding a chemical flood afterwards. Yeah. Another benefit that we saw, it was not only that we were increasing the oil recoveries, you know, under laboratory environment, yeah, but we were using a reduced amount of polymer in comparison of injecting the polymer, you know, like in the secondary mode, yeah. So, so we insisted that is like this optimization of water could be a very good platform for other EOR techniques that can be used. And a part of that, we were using this polymer, which is like a very good seller from SNF. It is a very basic polymer because it's diluted in the low salinity. So we didn't use one of the most expensive polymers. It was use one that is fairly more economically, and we use a lot less of the polymer. So here we're trying to improve the efficiency of all types of flood, the smart water and the chemical floods. And we see a very good synergy in terms of ultimate oil recovery, but also in terms of the usage and concentrations of the chemicals that can be reduced. And I think that that's very important. Yeah. In relation to the pressure drops, of course, I wanted to highlight that that's under a confined equipment where we have a core closed from the entire body. We have the inlet and the outlet open. So of course that we're creating some synthetic environment where the pressure drop, it's usually larger, you know, we're aware of that, you know, and that's also very common for typical water floods. And no, and also I think that this is an important comment that I wanted to add, you know, this type of increment in efficiency. Yeah.
Okay, thank you very much, Ivan. We have a couple of questions here. One of them is to Jan. Miguel Gilali says, is there any formation damage using PF?
In general, what we see is that the polymer flood enhances the injectivity, funnily enough. What it does is that if there's fines accumulated around the injector, the polymer will be, let's say, better sweep away around the injector near wellbore. On the other side, from a producer point of view, the polymer is, when it arrives at the producer, is either being adsorbed or has also been sheared. So the last part of the polymer flood has more sheared polymer in there. You still have to look at your completion to make sure that your polymer doesn't impair your completion. So yes, you have to be you have to engineer around it, you have to engineer with it, and you have to really look at it. But from an injection point of view, what we see is that the actual injection is better with the polymer. From the production point of view, we don't have many issues with it, but you need to take care of it. Yes.
Okay, for the last two questions, those questions are for Flavian, although he's not here right now. So I'm gonna read them, and if any of the other speakers want to answer, that would be great. In EOR processes, are you accelerate production or increase reserve?
It's a bit of both. If you look at a polymer flood, the polymer will actually go into bypass zones because the mobility ratio is optimized, and therefore it's kind of a little bit counterintuitive, but the polymer will go in to the lower permeable areas, preferably over water, which will just stay in the higher perm areas. So yes, you will sweep more, and therefore it will be an additional recovery increase, and on top of that, it's also acceleration as well. So it's both.
Okay, and we have another one here from Julio Herbas. Can you comment on the results of the offshore Angola Dahlia polymer project in 2013? It was suspended because operational issues. I wonder if the problems were fixed. I don't know if you can answer.
No, I see you smile here, Jan. I want to understand.
No, that was before my time, but maybe Antoine knows something about it. I don't know.
Yeah, well, so the problems were understood and not needed to be fixed because basically the project has been stopped. So operational issues were basically sand issues into the injection well. That's because of consolidating issue. But the projects didn't have any follow-up. So basically everything was understood and could have been fixed probably, but there was no follow-up.
Yeah, maybe I can jump in really quick here and maybe open the discussion to speakers. I know we're kind of going all over the questions now, but I mean, looking at the wider lens here and having a bird's eye view, we see that polymer flood and chemical EOR, and we see the advancements in surfactant really happening. So it's good to see that quick adaptation that the companies and customers are doing so far. There are hundreds and hundreds of projects that are also in the pipeline. A lot of it have been implemented. A lot of polymer floods have been finished and dusted off, and then people were happy with the result. And now we see with a few presentations that we were talking about, and in the lens of, or the theme of IEA, we see that there is a sustainability benefit. We are contributing to neutrality here with polymer flood. So maybe if I want to really ask a question here is that what took us so long, to get to that stage, and how do we advance? Maybe I'll let Antoine speak for a bit here, and maybe go back to Jan or other speakers if they want to weigh in.
I think this is also what I try to put in the presentation. When you look from an engineering perspective, we all know that water flooding is not efficient in the vast majority of cases. It's been very convenient because there is water everywhere and it's cheap. But when you look at how much water we produce now and how much oil is left after, I don't know, many years of exploitation, the thing is we probably just repeat what was done just because it's easy and convenient, but not very efficient. And how do we change one routine to the other? I think this is probably the most difficult question to answer, and it's not an engineering question. It's a social psychology question. Basically, it's we have the same in all the environments now, which is how do we change? How do we help people going from one routine to the other? I don't know, for example, flying less or using less the car, or it's very difficult. So I think this is a question I won't be able to answer. It's just from an engineering perspective, and for me, it doesn't make any sense, that's for sure. Then how do we change that? Well, that's a very, very different topic. So we probably need to enlarge as an industry and to work with social psychologists that can go to our managers and financial people and try to change their minds. But it seems as technicians we failed. So let's try another approach, I guess.
Jan, do you care to weigh in?
If I look around, I think I'm the oldest fart here in the audience. So I remember, when in the 90s you say something like, okay, let's look at EOR, and there's a huge skepticism about the whole thing. And I think Antoine has hit the nail on its head. It has to do with my neighbor has done it, so then I might be able to do it myself as well. And it took a couple of projects that were successful for the industry to pick it up. Now, China has been huge and has advanced really, really fast, but the industry at large said, yeah, okay, that's just, we didn't listen enough to China at the time. And I think, therefore, we've missed huge opportunity afterwards, when it was more kicked off in the States, and things like PDO, Marmou was a good success. Then it started to pick up. And one of the observations I've made in the last years is, if you look at Argentina, CEPSA, YPF, they go one after the other. And I think that's a huge advantage. And you can see that everybody goes like, oh, all right, let's do it as well. Let's do it as well. So the oil industry is just a very conservative club, and it not invented here mentality has been there for a long time. And finally, that has been broken through a little bit. And especially in South America, it really kicks off proper. So I've got good hopes for the next 15 years, I would say.
Yeah, obviously, and I think as we were talking about surfactant, maybe switch gears, talking about polymers, but switch gears to surfactant. Maybe this is more magnified. The skepticism is when we talk about surfactant. But we see that there's a lot of research, a lot of work has been done, a few pilots here and there. Definitely here from where I'm sitting in Canada, we've heard a lot that was happening in the 80s and 90s. And maybe directed to Dr. Ivan here, maybe what is the technical or academic, or what the academia is doing in this regard is huge. But how do you translate this into an actual project implementation? I'll let Dr. Ivan speak first, speaking from the academia, and then if any speakers want to weigh in.
Well, we have been promoting, these new technologies like smart water in combination with other chemical EORs, and we see that there is a very important barrier when it comes to, let's say, medium to large companies in taking a risk and deploying EOR. And it is sometimes simulation. They want to have the risk very well controlled. And we observe that the current simulators, they're not capable of probably capturing all the chemistry of these processes. So when we're talking with managers, they said that, yeah, but if I need to defend, these ideas, I really need to back up with these simulations. And that is a view that has changed, literally from the 80s and 90s, where there was more experimental, more empirical tests, like even in EOR and in academia and in the industry. And now we're relying a lot on numerical calculations. So I think there should be like managers, that they are taking probably not more risk, because we're seeing that many of these processes are very well validated in the laboratory, and still we don't see many of these technologies developing, in companies. So we hope to see more development, of course. And what is happening in the meantime is that we're losing a lot of value by waiting and by not having, people who is taking the risk. In Norway, we have also some extra regulations on chemicals that are very strict. Yeah, but even though in improvements of standard water flooding, we see that there are many problems that could have been easily solved like more than a decade ago, and the industry still is relying on the easy solutions. So, well, it is a struggle that the entire industry, has to. But I think with the help of this creation of these communities, we start to propagate useful information, that can help us to advance and really bring efficiency into oil production. So,
yeah, definitely. I mean, as I'm wearing the two hats of polymers and surfactant in my current role, I definitely want to see that path forward. But maybe interested to try to see what Antoine has to say with the surfactant piece of things.
I think surfactants, there is a technical and economic challenge. So technical challenge, I think, can be fixed if we approach surfactant. For me, it would make a lot of sense to consider SP after polymer injection. Why? It's because polymer, you help the risk injectivity business case, you understand the reservoir, and you get your simulation model right. And having SP after P, the polymer is acting as sacrificial agent. So basically, you will lose a lot less surfactant because it's already covered by the polymer in the reservoir. And so you will also improve injectivity, and SP after P, basically you change wettability and you push faster. So from a technical perspective, it makes a lot of sense. And from an economic perspective, it also makes a lot of sense to consider surfactant polymer after polymer. There have been a few cases like this in the world. Karen in India is doing ASP after P. I'm sure they're also saving on the alkali when she's less reacting on the rock. So this can be considered. And there is the economic perspective, which is it was the chicken and the egg, because many SP were not implemented because there were too complex chemicals for which the manufacturing capacity was not existing because there were not projects. So the question is, when do you start? If you don't build capacity, no one will consider the surfactants, and etc. So these are, I think, the two things which one can be fixed. It's a technical part. The economic investment aspect is something that I don't have the answer to for sure.
Yeah, and maybe Jan, you can shed some light on, we talked about, the cost of things and how polymer is definitely, the key to go. I know you might be leaning more towards polymer, but where do you see also that conversation goes when there is a surfactant in the mix?
Yeah, so before I was with SNF, I actually managed several ASP projects for Shell. One of the issues is the risk of the investment of the surfactant. So the surfactant is the very expensive part of the investment. And that risk can be reduced by doing a phased development. So when I was doing Salim in Russia with Shell, we looked at a big bang development, which the costs were just, ridiculous. And what for companies now to do is say, okay, we're going to use the surfactant targeted at certain zones, certain areas, and we're going to move those installations around over the field. And by this, that means that you don't have huge investment of your surfactant in 3 years, but you spread it out over 10 years. I think that is the only way you can make it work, because your financial exposure, you're talking about billions for a field, and very often these fields are already in the later stage of their life. So for a company to invest billion per year in your chemicals, they're never going to do that. So from an economic commercial point of view, the phasing of the EOR development is key. And again, I think the moment somebody starts, and I'm with Antoine on targeted surfactant after your polymer, the moment somebody starts doing that, and we have good hopes at the moment. PDO is doing a ASP pilot. Middle East is doing ASP pilot in Kuwait and in India with Cairn Oil. They're all doing ASP pilots. They're all polymer experienced companies. So again, I've got good hope that the surfactants will be used, but they will be used after the polymer flood, or after a couple of years of polymer flood, and then you just go in with your surfactant. That's the way I see it, and phased. So not a big bang, but bit by bit, smaller parts.
Definitely, yeah, definitely not a big bang, but maybe I'll let Mehdi add in or weigh in as well if you want, Mehdi, if you have a question.
Thank you very much for all of the speaker. It's just I know we have a few more minutes. I just want to ask general question. I mean, if you're looking at the chemical EOR, especially surfactant or more extensively the polymer, most of the I know there was a comment, the implementation of these ones is a little bit complicated because of there's a lot of capital costs due to the dehydration of the polymer need to go through a lot of process. Yeah, I'm just wondering if maybe SNF or maybe you or some of the manufacturer capability can answer some of these questions I have regarding them. If you know the unconventional reservoirs, we are all using the slick water or there's sort of a polymer, yeah, and those one is a lot easier operational. I'm talking about operational. Is there any advances or we can use adopt those type of polymer that use in unconventional for conventional reservoirs? I mean, what I see on operational is a lot easier if we don't need to go through the dehydration type of activities.
That's a really good question. Yeah, go ahead, Antoine.
So the polymer family and chemistries are related into the fracking and the OR for sure. The only question you have is people in the fracking industry, I think, are losing efficiency just because the polymer they use is subject to the same types of degradation, which is basically oxidative degradation and these kind of things. So I think they could be more efficient. But regarding EOR, this is what you want to protect. So the polymer family can probably be related, especially if you have very soft reservoir conditions, low temperature, low salinity, I have no doubt. Regarding facilities, you really need still to invest a bit more to protect the viscosity. Then it's all about CapEx and what was presented by the other speakers like Jan or Flavien, for example. I think there is a way to start much smaller than what people were doing in the past or were studying in the past. And you will see that the CapEx in the end, and even the polymer cost, if you look at the whole cycle of production, energy, waste, and investment, it will be offset quite fast. Of course, depending on the oil price, this is not what I'm saying today, where everyone is very lucky, and also depending on the CO2 taxes in the future. But the experience that if you start small and maybe considering moving instead of reinvesting, it will be offset very nice and your depreciation cost will disappear fast. You can even have the unit and use it over different zones and reservoirs with decent volumes. So I think there are ways today to make it reasonably and economically sound, which we probably have to consider much more often than it was done in the past.
Okay, thanks. Thanks a lot, Antoine, for the response. I don't want to take a lot of time from your beautiful Saturday, but I think it would be time for us just to go over the second half of our webinar here. Thanks a lot for the beautiful questions coming from our audience and the speakers for answering and participating in this panel. And I think for now, I will pass